So good day everybody. This is my masterclass video number 3. So in this masterclass video, we will tackle integration using U substitution, integration by parts, using trigonometric substitution, using partial fraction, and double and triple integral. So first we have the U substitution. So the general integration formulas. So here we have first the integral of U the integral of u raised to n times your du. So the integral of un is simply u n plus 1 raised to n plus 1, oh my bad, u raised to n plus 1 over your n plus 1. And then add your constant. So here, the n should not be equal to 1. Negative 1, I mean. So where in this formula, n is not equal to 1. So we have here the second general integration formula. So in here, we have the integral of du over u. So the integral of d over u is equal to ln, and then your um, absolute value of u, and then you add your arbitrary constant which is c. So here, n is equals to negative 1. So in the third example, in the third formula, I mean, we have the integral of u of e raised to u times r du. So here, the integral of e raised to u is eu. Then add your arbitrary constant, which is c. So in the last example, or the formula, we have the integral of a here is our constant, and then raised to u times r du. So this will become au over our ln uh, absolute value of a, and then add our arbitrary constant. Um, so this is our example number 1. So in example number 1, we have the integral of x dx over x squared plus 4 quantity squared. So here we will determine our u next. So next we will determine our u. So our u here is x squared plus 4. So this is our u, x squared plus 4. So the derivative of u is 2x times r dx. So in our equation, in order to substitute ru and du, we'll make it the same in our du and u. So du here is 2x dx. In our equation, we have x times dx. So we will add 2 here. So when adding 2 here, we will add 1/2 in our outside the integral. So first we will put 1/2, and then times the integral of 2x dx, right, over x squared plus 4 quantity squared. Next, we will substitute our u and du. So we have our du over u, and then 1/2, right? So next we have a copy 1/2. We will put our u in our numerator. So this will become u raised to negative 2. Okay? So this will become u raised to negative 2 times r du. So then we will integrate it. So we put 1/2 here. The integral of u raised to negative 2 is simply u raised to negative 1 over negative 1. And then add our arbitrary constant. So this is 1/2, yes. So next, we will put it here. So next, we will simplify. So this will become 1/2, 1 over u, and then add our c. So next, wait, grow and c. So add our c. So next, simplifying, we will distribute now the value of u. So u here is x squared plus 4. So we have negative 1/2, 1/2 and then our 1 over u, which is our 1 over x squared plus 4, right? Okay, so then our arbitrary constant. So this is now your final answer. So for example number 2, we have the integral of x plus 1 times our dx, and then over the square root of x squared plus 2x, and then um, let's make it minus 4, right? Oh, so here we will distinguish our u. So our u here in this example is inside our square root. So this will become x squared. U is x squared plus 2x minus 4. Next, the derivative of u, which is 2x plus 2, then r dx, right? So we'll factor out 2 since it has common. So it is common in both terms. So this will become 2 times x plus 1. Then add your dx. So next, we will substitute. So again, since we have 2 here, we'll put 2 here and then 1 half outside the integral. So we'll put first the 1 half, and then the integral of 2x plus 1, and then times r dx, right? And then copy the square root of x squared plus 2x minus 4. Next, um, we will substitute our u and du. So this is now our du over u. So square it here. So square root will become raised to negative 1 up. So this is the same as square root. So next, we will simplify. We will integrate pala. So 1 half. Wait. So before integrating, we will transpose u here, then the denominator to our numerator. So we have, when transposing, it will become the opposite sign. So we have here negative 1 half. So u, the integral of u raised to negative 1 half, then our du, right? So next, we will integrate. So we have here, wait, integration. So 1 half, then u raised to 1 half. So negative 1 half plus 1 is equals to 1 half. And then 1 half here over 1 half times our du. No, no, no. And then you add our c galit, right? And then c. And then next, we will simplify. So now we have so here galit. So when transposing the denominator into the numerator, this will reciprocate. So and then it will become 2 over 1. So 2 times 1 half is this will cancel out kila. So this will that will become 2 over 2, which is 1, right? So we only have u raised to 1 half, and then add your arbitrary constant, which is c. So simplifying, so this substituting u, which is x squared plus 2x minus 4, this will become x squared plus 2x minus 4 raised to 1 half, right? And then add our c. Next, um, when this is now our final answer, or we have square root of x squared plus 2x minus 4, then add our c. Wait, plus c. So both are correct. Both are the same answers. So for the next topic, we have integration by part. So what is integration by part? So as we recall, um, the derivative of the product, which is which is the derivative of our first term and our second term. So the product of the first term and the second term. So according to this, we have the first term times the derivative of the second term. Okay, so UTV. So add this to the second term, copy the second term, and then take the derivative of our first term. So the u dv plus rv du. Okay, so if we're going to integrate both sides, wait, before integrating both sides, we'll find um, the udv here. So we will put udv here, and then we will transpose this to the other side. So it will the sign of this will be negative. So we have here the derivative of u v and then minus r v du, right? So if we integrate it, we have here the integral of u dv is equals to the integral of, so this will cancel out the integral here, the integral of, wait, right here. So this will cancel out. So it will only be uv, okay? So minus, copy the integral of v du. So this is now the formula for our integration by part. So for example number one, we have the integral of ln x times our dx. So we'll find here our u first and our dv galit. So the v, so u here is equals to ln x. This is our u, and of course this is our dv. So we have here ln x and then our dv, which is dx. Okay. So our du here, the derivative of ln x is dx over x. Okay. Next, the integral of v here is equal to x. Okay. So next, um, we will apply our formula, which is u times v minus integral of v du. Okay. So distribute. We have u v here. U is equals to ln x. So our v here is x. So put here x. Then minus the integral of v, which is x times r du, is dx over x, right? So next, since x here and this will become 1 over x, it will cancel out. So copy x ln x, and then the integral of dx is simply dx, okay? So it will become dx, and then simplifying further, we have um, x ln x minus x, and then add our arbitrary constant, which is c. So this is now your final answer for example number 1. So let's proceed to example number 2. So for example number 2, we have the integral of secant cube theta d theta. Okay. So first, we will separate secant here in order to apply our u du. Okay. So it will become the integral of secant cube, secant theta, uh, and then times it, multiply it with secant squared. Okay. So this is the same as theta galit d theta. So this is the same as secant cube theta. So now we have our u and du, dv galit u and our dv. Okay. So u here is secant theta. Du here, the derivative of secant theta is secant theta times tangent theta d theta. And our dv here is secant squared. Oh my god. Secant squared theta d theta. Okay. The integral of that is equals to tangent theta. So now, let us distribute it to our formula. So we have here secant theta. Secant theta, okay? Tama. Secant theta times our tangent theta. And then minus it to the integral of tangent theta. So this will become tangent squared theta because we have here tangent theta. Okay, we have here our v du, which is our v is tangent. So we have two tangents here, so that's why it will become tangent squared. So times our secant theta, d theta. Okay, so next we will transpose this using trigonometric identity. So copy secant theta, tangent theta minus. So this will become tangent squared theta will become secant squared theta minus 1. Okay, and then add our secant theta, d theta. So next, okay. So next, we will distribute secant theta. So by distributing here and then distributing here, we have secant cube theta minus okay. Yes. Since this is negative, this will become positive. All right. All right. So this will become secant theta times tan theta tangent theta minus secant cube theta. Then secant cube theta d theta. Distribute this also, and then add the secant theta here. So secant theta d theta. All right. So since this term is equals to our where it is, so since that term is equal to this term, so we'll put here 2. Okay, 2 the integral of secant cube theta d theta. Okay, then copy this secant theta tangent theta, and then yeah, so negative here will become positive when putting it to this side. So copy plus secant. So secant theta here will become the integral of, wait, we have here the integral left. So secant theta here will become the integral of ln secant theta plus tangent theta. Times tangent of theta. This is the absolute value, and then plus your arbitrary constant. So simplifying this, we will divide this by 2 and then divide this by 2. We have 1/2. This will cancel out, right? Okay, so we have 1/2. Copy secant theta tangent theta plus ln ln theta ln theta ln absolute value of secant theta plus tangent theta. Okay, this is plus gali, kaya may plus gali. And then other arbitrary constant. So this is now your final answer for example number 2. So for our next topic, we have trigonometric substitution. So in trigonometric substitution, we have 3 types. So this is for type 1. So if the integrand contains a squared plus x squared, we will use x is equals to a tangent of theta. So in our first example, we have the integral of the square root of 4 plus x squared times your dx. So first, we will let x equal to, since a here, we have here a squared is our 4. So the square root of that is our 8, right? So the square root of 4 is 2. So we'll put 2 here and then x, and then we will put the tangent of theta. So next, we'll find the dx. So the derivative of tangent is secant squared. So we have here 2 times secant squared theta d theta. Okay, so next, we will substitute x here in our dx. So we have the square root of 4, copy 4, plus, since this is squared, we will square the 2 here. So this is 4, and then square the tangent squared theta. And then our dx is 2 secant squared theta d theta. This is squared. Okay. So next, since in here we have common, we will factor out 4 here because that is our constant and it is common in the both terms. So this will become the integral of 4 and then u1, because this is factor out, and then 1 plus tangent squared theta. Okay. So that is now, and then the square root pala. And then copy 2 secant squared theta d theta. So next, since it has common, it has constant, we will factor out the constant. So in here, the square root of 4 is, wait, the square root of 4 is 2. We'll put 2 here. We'll put 2 here, and then the constant here is 2. So this will become 4, right? So this will become 4. And then tangent, 1 plus tangent is equals to secant. Secant squared theta. Okay, so the square root of the secant squared theta is secant. So we have here 3 secant, secant cube theta d theta. Okay, so for our next step, we'll use the du and u. We will integrate it by parts. Okay, so we have here, wait. So by using integral of parts, we will separate this in order to get ru and du. So we have here 4 then times the integral of secant squared theta times secant theta. Secant theta, okay. Secant theta d theta. So now we will determine now ru and dv. So this is our this is ru, and this is ru, and this is now our dv. Okay, so we put here u is equal to secant theta, and then our dv is equals to secant squared theta d theta. So that is the same, right? So our du here is equals to the derivative of secant is secant theta times tangent of theta. Next, the integral of v of secant squared is tangent. Okay, tangent theta. So now we have our values for u and for u dv. So we will use the integration by parts. Wait, so this will become, let's put it here. So this will become the secant squared, copy this, secant squared theta d theta is will become the integral of secant squared theta d theta will become secant um, secant theta times tangent of theta gali tangent of theta and then minus secant theta tangent of theta tangent squared theta gali and then r d theta. So next, this is cube by the way, so we will use this. So next, this will become we will okay. So tangent squared theta will become secant squared theta minus 1. So we will put that there. So it will become secant cube theta. Diretson ko na lang. So this will become the copy secant tangent and then minus copy secant here, the integral of secant theta, and then this will become secant theta, secant squared theta minus 1, and then your d theta. So next, we will multiply this term to that term, the binomial here inside. So we have copy secant theta, tangent theta, and then minus, this will become secant cube theta. And then this will become, since this is negative and this is negative, this will become positive integral of secant theta. Then times your d theta. Alright. So next, since this is secant cube theta d theta, we have here secant cube theta. And then we also have here secant cube. So we will combine that. So this will become 2 times the integral of secant cube theta d theta. And then copy the remaining terms. So it will become secant theta times tangent of theta. And then the integral of secant theta is ln wait, this will become plus ln of the integral of secant theta, which is secant theta tangent of theta. That's it. And then our arbitrary constant. So next, we will divide this in 2. Alright, so this will become 1/2 secant theta tangent of theta ln secant theta plus tangent of theta. Then your arbitrary constant. So this is not our final answer. So in our final answer, we will find we will ano ganito tawag ko na? We will substitute secant theta and tangent of theta in terms for our x. Okay? So we will do that now. So Dalawig sa kasampol ba? So for solving in the tangent of theta, we have here, let's say have here x equals to 2 tangent of theta. Alright, when we solve for tangent of theta, this will become tangent of theta will be equal to um, x over 2, right? And then solving for the second theta. So first, gali, we have here our triangle. So this is our angle, and this is your hypotenuse. I mean your opposite over adjacent, and then your hypotenuse. So here are so we know that tangent is equals to opposite over adjacent. This is opposite over adjacent, right? So now this is your opposite, so this is your x, and then this is your 2. So for solving the hypotenuse, um, it is only the square root of the sum of the terms of the squares. So this will become 4 plus x squared, the square root of 4 plus x squared. So now we will solve for the second theta. So second theta is equals to hypotenuse over adjacent. So this is now our hypotenuse. So we have 4 plus x squared, and then our adjacent, which is 2, right? So we have now the terms. We have now the okay, the terms. So we have now the terms in the second theta and the tangent of theta in terms of x. So we will use that. So next, so so we will go back to our given. So this will become 4 times second cube theta d theta. So our second of theta, second cube theta, as we'll know, second cube theta d theta is equals to the 1/2 of the 1/2 is equal to 1/2 second theta times tangent of theta ln of second theta tangent theta, and then your arbitrary constant. So this is the value of our second cube theta, right? So we will distribute that. So this will become 4, and then the integral of second theta is 1/2. Copy second theta, copy tangent theta, copy ln, and then the absolute value of second theta tangent of theta, and then your arbitrary constant, which is c. There you go. So now, this and this will cancel out. So this will become 2, right? So next, so this is 2 times second theta tangent theta, and then we'll distribute here. So this will become 2 tangent ln of second theta tangent of theta, then your arbitrary constant, which is c. Okay, so now since we know that our tangent theta is equals to x over 2, and our second theta is equals to the square root of 4 plus x squared over 2. So this is x squared over 2. So now we will distribute this in this equation. So we have 2 secant theta is 4 plus, we have here 4 plus x squared over 2, right? And then times tangent of theta, which is x over 2. And then 2 ln secant theta, which is plus 4 plus x squared over 2, and then plus your x over 2, and then your arbitrary constant. So simplifying further, we have this will cancel out. Okay, so simplifying, we have x over 2 square wait, x over 2 times the square root of 4 plus x squared, and then plus your 2 ln. This will become one term, so this will become 4 plus, let's put x first, so this will become x square root of 4 plus x squared, and then this will become over 2, and then your arbitrary constant, which is c. So now we have your final answer for our type 1. So this is your type 2. So in type 2, we have, if the integer contains a squared minus x squared, we will use x a sine of theta, or x is equals to a cosine of theta. So in this, we have here our a squared and then our x squared. So in this equation, we have y squared, right? So first, we will let y, so this is your x, diba? So square root of that is 3, square root of 9 is 3y. 9y squared, square root of 9y squared is 3y. So we'll now know the value of our x. Okay, so next, this will become, since this is 4, the square root of 4 is 2. So we'll put here 2 sine. We will use the sine of theta in this example. So next, we'll find for the dy. So our dy here is 2/3 cosine theta d theta. All right. Okay. So why 2/3? Because we have here the derivative of 2 sine theta. Okay. So next, we will distribute the value of 3y and our dy. So we have here 2/3 as our numerator, 2/3 cosine theta d theta. And then this will become the square root of 4 minus 4 sine squared theta. So why this is sine squared? Because we have here our value of 3y, so when this is squared, this is squared and this is squared, it will result to this. Alright? So that is now our x squared. So next, we have here common. We have here our constant. We will factor out now our constant. So factoring out the constant, this will become 4, and the square root of 4 will become square root of 4, and then 1 minus sine, become 1 minus sine squared theta. Okay, so copy 2/3 cosine theta d theta. So next, since this will become square root of 4, so this will become 2, and then 1. So diretsuhan ko na lang. So 1 minus sine is equals to cosine, right? 1 minus sine squared theta is equals to cosine squared theta. Okay, so the square root of cosine squared theta is equals to cosine of theta. So we have now our 2 and then your cosine theta. So the square root of 4 is 2 and the square root of 1. So this is 1 minus sine squared. This is cosine squared. So the square root of cosine squared is cosine. So we have your cosine of theta. So in our numerator, we have 2/3 cosine cosine theta. So this will cancel out and the 2 here will cancel out. So this is the integral. So we have now this will cancel out, diba? So I have now 1/3 integral of d theta. Okay, next. The integral of d theta is simply theta. So this is 1/3 theta plus your arbitrary constant, which is c. So we'll solve for the value of our theta. So here, let's say we have 3y is equals to 2 sine theta. So we will factor out 2 here. So this will be by 2 divided by 2. This will divided by 2. So this will become 3y over 2 is equals to sine theta. Okay. So when we put arc sine in this to the left side, this will become arc sine. So theta here will become 3y. I mean arc sine. This will become arc sine times your 3y over 2. Okay, so now we have the value for our theta. So let us distribute it. So this become 1/3 arc sine of 3y over 2. Then your arbitrary constant, which is c. So now we have your final answer for your type 2. So for our next step, we have if the integrand contains x squared minus a squared, we will use x is equals to a secant of theta. So we have here, for our example, we have the integral of dx over the square root of, the square root of 4e. This is 4e, and then raised by 2x. Then we'll use minus 9. So first, again, we will let we will let 2x. So the square root of 4 is 2, right? So this will become 2e raised to x. So this will cancel out the square root here, and the 2 in the exponent will cancel out. So we have 2e raised to x. So here we have our our a, which is 9. So the square root of 9 is 3. So we have now secant. So we'll put secant theta. Next, you'll find the derivative of 2ex dx. So this will become 3 secant theta, tangent of theta, and then we will we will divide it by 3 secant of theta in order to get tangent of theta. Okay, so we have 3 secant of theta, tangent of theta over 3 secant theta. So this will cancel out. So we only have tangent theta d theta as our 2 e raised to x dx. So now we will distribute it to our equation. So we have tangent of theta, since our dx is tangent of theta, d theta, and then over this is the integral gali. A second second squared theta kay squared. Second squared theta minus 9. Alright. So for the next step, we'll we will square root we will root the term inside the square root symbol. It's a square root sign. So we have tangent of theta, the top, d theta, over the square root of a second of the square root of 9, gali dyan 9. Square root nga lang ko sa a. The square root of 9 second squared theta, d theta, squared of 9 second theta, 9 second squared theta minus 9 is 3 minus, 3 tangent theta. So tangent here and tangent here will cancel out. This will leave us the 1/3 d theta. So the integral of d theta is will become 1/3 theta and then your arbitrary constant, which is c. So next we'll find the value for our theta. So we have here 2e raised to x is equals to 3 second of theta. So we'll find the value of our second theta, our theta. So this will become okay. So we will divide this term by 3. So this will become 2e x is the x over 3 and then second of theta. So transposing second theta in the left side, we have theta is equals to arc second 2e raised to x over 3. So now we'll distribute it with the value of our theta here. So this will become 1/3 arc second 2e raised to x over 3 and then your arbitrary constant, which is c. So on to our next topic, we have partial fraction. So in case number 1, we have distinct factor. So we have n. In distinct factor, we have n over x minus a and then x minus b and then x plus c. So in distinct factor, if the denominator of the term is factorable and its factor are different from each other, to each other. So this is different from to each other. So this is called your distinct factor. So we can rewrite that as a over this term, which is x minus a, and then add it with b, and then the second term, which is x minus b, and then add that to your third term, which is x plus c. So this is now your formula. So we will use this in our first example. So our first example, we have wait, we have the integral of 4 over x squared minus x minus 2. So first we'll factor out uh, the the term here. So we have 4 here at the top. Then so factoring this out, we have x plus 1 times your x minus 2, right? So next, we will apply the value, we will apply the formula in this equation. So we have here a over x plus 1 and then b over x minus 2, right? Right here. So next, we will use the cover up method for finding the value of x. I mean the value of a and b here. So this will become the cover up method. So cover up method. So by using cover up method, we will cover up the value of a, which is x plus 2 in this equation. So we will cover up uh, x plus 1 gali. So we'll, this term will be left. So this will become 4 over x minus 2, right? So next, we will solve for the value of x here. So for the value of x, um, we'll find, we will think of a number that this equation will become 0. So so x here is equals to -1. So -1 plus 1 will become 0, right? So next, we will substitute the value of -1 in our x. So we have 4 over -1 minus 2, and this will become -4 thirds. So now we have the value of our a. So next, we'll find the value of our b. So our b here is x minus 2. We'll cover up x minus 2. So the remaining will be 4 over x plus 1. So we'll find the value that um, x minus 2 will become 0. The value of x here will become, when substituting the value of x here will become 0. So x is equal to 2. So 2 minus 2 is equal to 0. So then substituting the value of x here, which is 2. So this will become 4 over 2 plus 1. So we have positive 4 thirds. So now we know the value of our a and b. So next, substituting that. So we have the integral of -4 thirds over x plus 1 dx here. And then plus the integral of the second term, which is our 4 thirds over x minus 2. Then your derivative x, which is, and then the integral of 4 thirds of this term will become -4 thirds ln of the absolute value of x plus 1. And then the integral of this term will become 4 thirds ln x minus 2. And then your arbitrary constant, which is c. So this is now your final answer using the cover up method. So this is your case number 2, the repeated linear function. So we have here the numerator over, for example, we have here x squared, x minus 1 quantity raised to 3, right? So um, so we'll represent this as a over x. So since this is repeated, we have here plus b over x squared. And then your c is x minus 1. Then since this is repeated, we have here d over x minus 1 squared. And then this is squared. And then your plus e over x minus 1 quantity cube. I mean quantity cube, right? So now, this is our formula. So we will use this in our example number 1. So for example number 1, we have we have the integral of x dx over x plus 1 times x plus 2 quantity squared. Okay, so we will use first we can use the cover up method. So we'll represent this first. So this will become a over x plus 1 plus b over x plus 2 and then plus your c. So since this is repeated, we'll copy it and then put squared, quantity squared, this term. So, and then multiply it by your dx. Yeah. So we will use our cover up method. So by using cover up method, we can only solve for our a and c. Why? Because we have here um, we have only a and c as the given. So x plus 2 here is not given. So for a, we have we will cover up the x plus 1. So we have x over x plus 2 quantity squared. Okay. So in here, we'll find the value of x, which this will become to 0. So we have here x is equals to -1. Okay. So next, so this is x and x. So we have -1 over -1 plus 2 will become 1. Then quantity squared. Then this is equals to -1. So in letter C, we'll cover up x plus 2. So this will become x over x plus 1. So what is the value of x that will make this 0? So we have 2. I mean -2. So x is equals to -2, right? So next, we will distribute the value of x. So this will become 2 -2 over -2 plus 1. So simplifying, we have 2. So we now know the value of our A and C. So in solving for RB, we'll use the substitution method. So in substitution method, um, we will use first in using substitution method. First, we will multiply this term to the with the LCD or the lowest common denominator. So this is our lowest common denominator. So we will multiply that by x plus 1, uh, x plus 2 quantity squared. So now we will distribute this x plus 1. So this will cancel out. So your a here become to 1. So let us put it like this. Become x is equals to a. So cancel out. So x plus 2 will be left. X plus 2 quantity squared will be left. And then your b. So x plus 1, x plus 2, and x plus 2 here will cancel out. I mean, may isa pa gali, may x plus 2 since this is squared. Then your c. So this is cancel out. So x plus 1 na lang ang mabilin. So next, since we know the value of our a and the value of our c, we'll substitute that in this equation. So we have a, which is -1, so we put it as negative, and then copy, and then your b, copy b, x plus 1, x plus 2, then your c, which is 2, put it here, x plus 1. Okay, so in this equation, we'll find the value of x, which come to when substituting, make sure that the value of b will not become to 0. Okay, so we will use x is equals to 0, right? So 0, since x here equal to 0, so this will become 0. Then substituting 0 in the x will become 2 squared, which is 4. Since this is negative, so this is negative 4. And then your b, which is 2. Since this is x, this will become 1. And then x plus 2 is 0 plus 2 is 2. And 2 times 1 is 2. So this will become 2b. Okay. Next is here. So 0 plus 1 is 1. Then multiply it by 2. This will become 2. So now we'll solve for the value of b, which is you multiply both sides by b. We have 4. Then minus 2. Minus 2. And then over 2. Okay. So simplifying, b will be equal to 1. So we have now our values. We have here b is equal to 1. So we have now our values. So next, we will substitute the value of a, b, c in this equation. So we have, let us put that, wait, put ang tag, yeah. So this will become the integral of a, the value of a is negative 1 over x plus 1, and then your b, which is 2, over x plus 2, and then your c, which is 1, which is 2. Ano sa ko to? B gali dya. Sorry, my bad. So this is b gali. So 2 here is 1, which is our b gali. So b is 1. Nagsala lang. X plus 2, and then your c, which is 2, over x plus 2 quantity squared. Then multiply it to your dx. Okay? So next, we'll integrate it. So integrating, we have negative ln x plus 1 plus ln x plus 2. Then your last term will become negative 2 over x plus 2. Okay. Then your arbitrary constant, which is c. So now, for your case 2, you have your final answer. So for your case 3, we have quadratic factors. So we have here your numerator over a quadratic equation, which is ax squared, wait, we have here ax squared plus bx, and then your plus c. So expanding that, we have a over your denominator, which is ax squared, is x squared, plus bx, and then your plus c. So near a, this will become a will be multiplied by the derivative of the denominator. So the derivative of ax squared plus bx plus c is equals to 2a plus b. So this will be multiplied to a, and then add your b. So b here will become over ax squared plus bx plus c. So now we have our formula. So next we will proceed to our example number 1. So for example number 1, we have 4 over x minus 1, and then x squared plus 9. Right. So this is x squared plus 9. So next, wait, times your dx. So next, we will expand this equation. So it will become a, and then over your first term, which is x minus 1. Wait, this is the integral. So next, then add this, well, the second term, which is your b. So this is your second term, x squared plus 9. Since this is x squared plus 9, we'll multiply it, we'll multiply b to the derivative of the denominator, so which is 2x. Then add your c, and then this will become x squared plus 9. Okay, so next, in order to solve for this equation, we will use wait, times your dx pala. We will use your coefficient method. So in the coefficient method, we will copy the sign, coefficient method. Ay, share my. So we will copy first our given. So this is 4 over x minus 1, and then x squared plus 9. Okay, amo na na. Tapos, and then copy your expansion. So this is a over x minus 1 plus b times your 2x over x squared plus 9, and then your c, x squared plus 9. And then, so next, we'll multiply it uh, to the least common denominator, which is your LCD, which is right here. So we'll multiply it by x minus 1 times x squared plus 9, right? So when we multiply it, in the left side of the equation, with this will cancel out, x minus 1 will cancel out, x squared plus 9 will also cancel out. So leaving us 4. So next, x minus 1 here will cancel out. So this will become a times the x squared plus 9. And then x squared plus 9 here will cancel out. So this will become b times your 2x, then times your x minus 1. And then in your c, we have, we'll cancel this out. So we have x minus 1. Alright. So next, we will combine this. So this will become 4, copy a, x squared plus 9, and then the b here will become 2x squared minus 2x. Hindi, gali, pag i-combine, we will multiply, gali. So, right. So then your c, x minus 1. Okay. So next, we'll solve for the equations. So for equations number 1, we'll find how many x squared in the equation. So first, the x squared in this side is none. So this is 0. So we have the x squared in our a. So we have your a, and then you have your in our b. Oh, this is b gali. Okay, so I have 2. Then add it to b. So this is your equation number 1. So we'll find how many x are there in the equation. So on the left side, we have 0. Then the right side, we have negative 2b plus c. here, and here. I mean, isa dire sa negative 2, isa ka x, tapos isa man di sa c, which is positive x. Okay, so next, we'll find for the x raised to 0 or the constants. We call this as the constants. Right. So, in here, we have 4. So, the constant here, we have 4 in the equation here. Next, we have 9 in our A. And then in our B, we have negative C for our equation number 3. So, this is your equation number 2. So, by solving in our calculator, we'll find the value of A, B, and C using our equation number 1, 2, and 3. So, using calculator, we have first, we have A is equals to 2 over 5. And our B is equals to negative 1 over 5. And then our C is equals to negative 2 over 5. So, substituting our A, B, and C to our equation, we have the integral of 2 over 5, which is our A, over x minus 1, plus your B, which is negative 5, 1/5 kile, times your 2x, x squared, plus 9, minus 2/5, 1 over x squared, plus 9. And then your dx. So, simplifying this, we have 2/5 ln x minus 1 minus 1/5 ln your x squared plus 9. And then in your C, we have 1 minus 2/5 arctangent. Wait. 2/5, 1/2, 1/3 1/3 arctangent. And then x over 3. Then your arbitrary constant, which is C. So this become plus C. Oh wait. Di ko mag-type. Plus C. So this is now your final answer for this case number 3. So in this topic, we'll discuss about double and triple integrals. So first, in our first example, we have a double integral, which is the integral of pi over 2, and the integral from 0 to pi over 2, and then the integral from 0 to 5 x sine of y, sine y dx, and then your dy, since this is double integral. So first, we'll solve for the inner part. We'll start from the inside. So the integral of x sine y dx from 0 to 5. So sa integral of 0 to 5 x sine y dy, sine y dx, sine y dx, okay, is equals to the integral from 0 to pi over 2, since the integral of sine y dy, sine y, x sine y dx from 0 to 5 over 2 is equals to x sine y times your x squared over 2, and then your 0 to 5, your dy. So sine y here is constant. That's why we will take out constant first. The constant first, right? So this will become the integral sine times the integral of x from 0 to 5. So the integral of x is x squared over 2 from 0 to 5 dy. So we will now distribute the value of the integral. So we have here 0, copy pi over 2, copy then the sine y, and then when we distribute, we have here 25. Since this is x squared, the upper limit is 5. So 5 times 5 is 25, then divided by 2. And then your lower limit, which is 0. Then your dy. So simplifying this, we have so next galet. So when we simplify this, we have the integral of pi over 2, 0, sin y, then your 25 over 2 dy. Right. So next, um, we'll solve for the outer term, for the second integral. So the integral of sin y 25 over 2 dy from 0 to pi over 2, we have first take out the constant, which is 25 over 2. And then the integral of sine is cosine. So this will become a negative cosine. So this will become negative cosine y. Right? Cosine y. And then the limits from 0 to pi over 2. Next, copy 25. So since this is negative, we'll put here negative 25 over 2. And then cosine, since cosine is equal to pi over 2, so this will cancel out. Cosine here, this will lead us to cosine, then your y will be equal to pi over 2. So cosine will be cancelled out. So this will cancel out, this will become 0. And then your second term, which is minus cosine, 0. So this will become 1. Okay? So your answer will become negative 25 over 2. So this is your final answer for double, for example number 1. Next. So for example number 2, we have triple integral from the integral of the integral from 0 to 3, integral from 0 to 2, and then from 0 to 1. X, y squared, z cubed. Then your dx, dy, dz. Okay. So first, again, we'll solve for the first term, then second, then the third equation. So for the first term, we'll copy the 0 to 3, the 0 to 2, and then integrate x here. So y squared is constant, and then c squared is constant. So only x here is will be integrated. So this will become x squared over 2. The limits from 0 to 1 dy dz. Okay. So next, we'll distribute the value of 1 here. So this will become 0 to 3, 0 to 2, y squared, z cubed, then 1 half, come 1 half, and then multiply it to your dy dz. So next, we'll solve for this term, for the second integral. So copy 0 to 3, then 1 half here is constant, right? I mean, this will become 2 cube. Okay. Diretso ka lang 2 cube over 2. Then your y cube over 3. The limits from uh, 0 to 2. Okay. Then, pagli, may dz pati gali. So, simplifying this, we have 0 to 3. Then, we have z gali dyan, z cube over 2, y over 3 over 3. Okay. So, this will become z cube over 2. And then, y distribute 2 times 2 times 2 will become 8 over 3. Okay. Then your dz. So this is dz gali. This is dz. So solving for the last term, we have since this is constant, put it the front in the first before the integral. So the integral of z cube is equals to uh, z to the fourth over 4. Z to the 4 over 4. Okay. And then from 3 uh, with limits from 0 to 3. So this will become 1/3, simplifying 1/3, 4 raised to 4. Okay. So multiplying that, we have 81 over 3, which is 27. So this is your answer for number 2. So um, that so this is it for my master class number 3. I hope I hope you learned and understand anything. Um, and then thank you for listening.